Hello, I am Miro, and this is the last film of the wind turbine series of the Renewable Energy Technology course. We are at the lecture 3 for the wind power series, a very quick and short review of environmental impact. We will conclude the whole lecture series with this section. There's a lot more to talk about, of course, and we here will only touch upon the most important issues. You are free to explore further and deeper each of those topics and subtopics. What is the impact of wind turbines? Definitely there is always an impact. First of all, they sit over there where they should be visible from everybody because they should be sitting in the open wind. There is noise. There is interaction with all kinds of life around, both wildlife and human-made life. There is visual intrusion, yes. There is flickering shadows, not always, but sometimes this can be very irritating. Some kind of interference with radio communication systems also. And we can add to all these direct effects, we can also add somehow indirect impact through other land destruction, erosion, human activities related to wind farm construction, maintenance, and so on. Material involved in wind turbine construction. This can be actually serious issues and will grow in importance more and more in the future. Let's look quickly at all of these major topics. Noise, definitely underestimated. Wind turbines are noisy, as any machine is, and we can divide the noise into two major sources. Mechanical, from the machinery inside the turbine, and aerodynamic, from the blades, or the interaction between blades and the wind flow, the fluid. The mechanical noise is the typical whining noise of any kind of machine, like gearboxes, cogwheels, generators, shafts, etc., inside. Also, other small devices are emitting noise, sometimes fans, cooling fans in the electronic devices, any kind of other auxiliary machinery that exists inside the turbine. It is comparatively easy to handle the mechanical noise through improvements in the wind turbine construction, better isolation around to keep the noise inside the machine, not to spread out to the environment. It is a bit more difficult to handle the aerodynamic noise. But we already mentioned it, actually improvements are being made continuously and modern turbines are far quieter than first prototypes. Wind blades have improved, especially the tip, the end of the blade, which travel fastest through the air. It is the noisiest part of the blade, and it can still be improved a lot. One major rule of thumb is that the tip of the wind blade is not allowed to travel through the air, that's the translational speed, with higher than 100 meters per second speed, exactly because of the noise. And as long as you keep the wind turbine not to spin up too quickly, it will be comparatively quiet. Noise is often overestimated and compared to other typical sources of noise that we always have around us. Actually, wind turbines are placed among the most quiet devices. Of course, the noise varies. If you are sitting at the basis, at the foundation of a wind turbine or inside it, of course it would be more noisy. And usually the noise is around 90 to 100 decibels inside the machine or nearby, just under the machine. The moment you start going away from it, of course the noise level will decrease. And remember, decibels is a logarithmic scale. Each step here actually means times of increase or decrease of the noise levels, or actually it's a power law. Here we come to the threshold of pain, while here where we still have a quite substantial numbers of 30, 40, this indeed is a super quiet environment. And wind turbines are comparatively there if we are reasonably far away from them. And definitely there is nobody who lives immediately under a turbine. Not even an office or a factory would be placed immediately under the turbine. Everybody is hundreds of meters away always from the wind turbine site. So it's actually very difficult to hear the wind turbines. You have to go there just under it and listen very carefully. Other major issue is killing birds. And you may see popish text in this form, avian mortality. I don't know if you understand this, it doesn't matter. The point is that wind turbines do kill birds. All kinds of machines and man-made structures, even natural structures, very often actually cause death of birds or any other flying animals. But if we carefully measure the specific numbers, we would see that wind turbines up to now are definitely not the major cause of bird mortality. The main causes of birds being killed are buildings and windows. I have seen birds smashing into a window. And, well, birds do not see glass. They would see the building, they would see a frame, but they wouldn't see the glass. And very often they make mistakes in this way. I have seen birds hitting a car, or vice versa. I myself have been hitting birds with my car. You know. I have seen birds dying from many, many other causes. Well, of course, I haven't been living just beside a wind turbine. Otherwise, I would have seen also birds being killed by the wind turbine. But the main point is that any kind of wildlife, they aren't stupid. They aren't suicide prone, at least not always. They learn. And birds would very, very quickly adapt to a wind turbine existing somewhere or being built somewhere. I did find a very nice proof of that, and you can probably find even better sources out there in the literature. Radar calculations, measurements being done in Denmark in a really existing wind farm. This is down on the western side of the Baltic Sea, on the southern coast of Denmark, the Nysted offshore wind farm. You see, this is before the wind array was installed. It is a major migration track for birds. This is east-west, both spring and autumn, not really north-south, but definitely a major road for birds. First of all, if your wind farm has to be there because the conditions are best for your turbines, including depth, you would choose as far as possible not to put the machines exactly at the densiest, definitely, road for birds. You would put them here. And you can measure after a couple of years that birds started to avoid those turbines. They definitely see them. Even if they make mistakes, as in a traveling car, birds very often cannot calculate the speed. And so if it's a wind turbine just sitting there and rotating more or less with the same frequency, with the same rotational speed all the time, birds will learn how to calculate it and how to avoid it. You see the migrating patterns for the major bird flocks in the area. They still pass here, and they avoid as much as possible the wind turbines. Wind turbines, and especially the foundations of turbines underwater, are also deemed to be detrimental to the local environment. Actually, it's quite the opposite. Any kind of a solid structure, very often, especially in bottoms like the Baltic Sea and the North Sea, very, very shallow, sandy bottoms. Actually, any kind of a solid structure is a perfect playground for fish and a home for other animals as a reef. And this has been proven in various studies. The flickering shadow may not always be a problem, and sometimes, well, you don't always see it, but if the sun is low, very low above the ground, and if the turbine definitely is sitting in a place where the shadow reaches a residential house, for example, somebody living there sitting in the kitchen drinking coffee and just seeing the shadow passing by all the time, not only one shadow, but you probably have 3 blades in here, and you probably have also other turbines on top of the hill. It can be pretty irritating. The flickering shadows definitely are very local effects and not important everywhere and all the time, but they can be pretty irritating in certain locations, and people have been complaining about those. Another negative impact regarding communication signals is the interference with radio signals. As soon as we have a metal structure with rotating blades sitting out there in the open, definitely it might cause, first of all, a shadow of a signal or a reflected signal. It results on your old TV in a snowflake or snow, typical only for analog signals, which are still being used by military communication. And the army guys are quite unhappy still with wind turbine developments, especially with offshore wind farms and so on. However, these days, we switch more and more towards digital signals. And with the digital signals, you don't see any snowflakes. You either get it fully or you don't get it. So any kind of shadow might still be important in certain places, but no reflected signals are relevant anymore. And the problem is more or less solved. Land erosion can be caused by wind turbines, definitely not in a direct way, but indirectly through the human activity for constructing the wind farm, maybe also during the maintenance procedures and so on. And you can find such examples, for example, in Altamont Pass in California here. Definitely the hill was cut to construct the road. Now, once this happened in a very arid environment, it's basically a desert, and if it rains, it pours down. And if the wind is blowing, it usually does with very, very high speed, the small soil particles fly away and so on. Once the erosion starts, it might proceed and take all the hill down to the valley. Of course, you must construct the roads, first of all, to be able to install these machines. Even if these machines here, they were one of the very, very old and first ones ever being installed. Vestas from the 80s. But if we have to put now multi-megawatt size machines and need a much bigger and tougher road to carry the much more heavy machinery that we would use for the new turbines, which is being done everywhere, including in California and those hilltops, the problem might be much more aggravated. And once the erosion starts in such environments, it's more or less impossible to stop it. You're losing land with a very, very fast rate. Another issue which will grow in importance with the continued expansion of wind power is, well, the end-of-life issues, recycling or disposal of all kinds of components. It might seem easy for the metallic structures. Steel is easy to recycle and has a value. But many components, for example, magnets in the electrical generators and so on, many components in modern machinery, not the least batteries, contain rare earth expensive materials whose production is very polluting. So the life cycle analysis for producing a wind turbine becomes more important these days with the further improvements of technology. And indeed, the large number of fiberglass blades, and fiberglass is not easy to recycle, would sooner or later pose a problem. What to do with them? We drove them in a very expensive way once to the site, and what do we do after 20 years? Drive back the 60-meter long wind blade to a recycling point, or what? Would this cost be involved in the cost of the project? We are pretty much approaching the problem that nuclear plants have. It is very costly to tear them apart and to decommission them. This might happen with wind turbines, especially with the large multi-megawatt, many units sitting out there in difficult to reach places and having enormous components. We can talk much more about these topics, but let's summarize the most important issues. Wind turbines do have an effect on the environment. Very often it is a negative one. It is, though, often misunderstood or overestimated. neither noise nor any other similar impact on killing wildlife or destroying the natural habitat of species is true. Or even if it is true, it's not to such a large extent that some people can think. Both direct and indirect impact through human activities related to wind turbine construction, maintenance, and so on is relevant. However, all of those issues can be softened, can be solved by various methods. There are many more topics to consider, of course. We are forced to stop here. We don't have the time to continue. Including this last section, many other topics can be dealt further with by other teachers and other courses. Thank you for your attention.